Okay guys, let's take a look at some more problems, but this time we're not going to use the table as much as we did in the past. We're going to look at some other methods that will help us get the same results. The bottom line though, if you like the table and you like this method, use it every time. If you like one of the new methods that I show you, try them out. Regardless of which method you use, you'll still get the same results if you're doing the math correctly. Okay, so this time we have 16 meters and we want to convert it to centimeters. Okay, well we've been using the table in the past, so if you're going to use the method, we're going to call that method method 1. We'll call this method method 2. And method 1, it's the table method. Method 2, we're going to use conversion factors. To cross out units. So method 1 we use the table, method 2 you can just say cross out units or you're using a conversion factor here. So let's take 16 and bring it down so we have 16 meters here. And I want to ask myself, what do I know about centimeters? Well, I know that there are 100 centimeters in 1 meter. Well, this ratio right here is a conversion factor. It's a fraction that's written with two different sets of units that are equal to one another. So the number or value or the quantity in the numerator is the same as the quantity in the denominator. However, we have two different sets of units. And that's what a conversion factor is. So we're going to take 16 meters and multiply it by this conversion factor. Well, how did I know to multiply? Let's go back up to that note. If the number is small, you've got to make it large. So our number 16 meters is going to be small compared to when we convert it to centimeters, it's got to become large. The only way to do that is by multiplying. Another way of thinking about this is if you move to the right in the table, you have to multiply. So I'm going to make two more notes here. I'm going to put an R down with the circle. It's telling us we're moving to the right in the table. We'll put a little arrow over it to let us know what direction we're moving in. And then I'm going to write the word multiply. Well, guess what? If you have a large number and need to make it small, well, you're going to move left along the table. So let's put an L down and a circle around it. We can even put an arrow moving to the left above it. And that tells us we're going to divide. But the cool trick here is I have a number that's in the numerator. Remember, 16 written as a fraction would be 16 over 1. So there's a number in the numerator. You don't need to have that there, so in a second I'll erase it. But what we can see is that I have a number with the same set of units in the denominator. So we're going to cross the units out. So let's cross out those m's real quick. These two units will cross out. Notice the values did not get crossed out. But I do want to erase this 1 and this fraction bar. They're not needed. So whenever I see a problem set up where there's the same set of units in the denominator and off to the side, I can still cross them out. And now you're left with 16 times 100 divided by 1. If you divide by 1, it's going to give you the same value as the numbers in the numerator. So our new answer is 16 times 100. Don't get your calculators out yet. I'm just going to write 16 down and put a decimal down. And if you're going to multiply by 100, well, it tells us to move the decimal 2 spaces to the right. And we'll end with our decimal right here. Before I write the final answer down, let's check to make sure we should have moved 2 units to the right. Okay, I'm going to locate meters in the table here. I've located meters, and to get to centimeters, I have to move 2 units to the right. That's cool. So it looks like 16 meters is equivalent to 1600 or 1600 centimeters. And let's look at another problem. This next problem, I'm going to use a totally different method, and we're going to call this method method 3. And in method 3, we're going to set up proportions. And again, we're going to use conversion factors to help us set up these proportions. So let's go ahead and write that down, conversion factors. In this setup right here, it's just the start of something we're going to get into in the future, known as, I'm just going to write it down here, dimensional analysis. And dimensional analysis, it's just a fancy way of saying, hey, you're going to use conversion factors to move from one set of units to another set of units. So let's go change our pens. And this time our problem wants us to convert 450 grams to kilograms. So I'm going to set up a proportion this time. And I'm going to write it as I read it, or see it or say it. So grams first, kilograms second. So let's set up our blank proportion here with grams on top and kilograms on bottom. If I do it to this side of the equation, I've got to do it to the other side of the equation. So grams on top, kilograms on the bottom. And let's just extend these fraction bars just a tad. Okay, so now I can fill in these ratios with the given information or information that I know. Well, I'm given 450 grams. The 450 matches with grams, so I've got to match that in my proportion here. So I'm going to plug 450 in on top. And kilograms, well, we don't know how many kilograms there are, so I'm going to use a variable, and let's just use the variable b. But what about this other ratio off to the other side? Well, use your formula chart. Take a peek and ask yourself, how many grams are there inside of 1 kilogram? And you'll see that there are 1,000 grams to 1 kilogram. From here, it's just a matter of taking the cross products. I'm going to change pen colors. And I'm going to, as I take the cross products, just pretend that the units aren't there anymore. I'm just kind of going to cover them up with a blanket or something and hide them with a cloak of invisibility for now. So now I have b times 1,000. I can put that over here. So 1,000 times b is equal to, well, 1 times 450, or simply 450. Let's go ahead and get just a little bit more room on the screen here and ask ourselves, what's our overall goal at this point? Well, the overall goal is to isolate the variable. How can I undo multiplication? Well, the opposite of multiplication is division. So let's divide this side of the equation by 1,000. That will help to isolate the variable b. If I do it to this side, I have to do it to the other side. That keeps the equation balanced. So I'm going to divide by 1,000 on both sides. Well, multiplication of 1,000 and division of 1,000 are opposites. They'll cancel out. So let's just continue on. Those cancel out. And I'm left with, well, it looks like we need a little bit more room to write here. So I'm left with b is equal to 450 divided by 1,000. Well, if the decimal is here for 450 and I divide by 1,000, that's the same as dividing by 10 3 times. So I'll move the decimal 1, 2, 3 units to the left. Before I write down the final answer, let's go and check that work in our table. Okay, so we're going to start at grams, which is here. I've located it in the table. It's a base unit. And I've got to move 1, 2, 3 units to the left to get to kilograms. Well, if I had to move 1, 2, 3 units to the left in the table, that means at the start of the problem, I would have moved the decimal 1, 2, 3 units to the left. So down here within the problem, when we divide by 1,000, we'll move the decimal 1, 2, 3 units to the left. So b is equal to 0.45 kilograms in this problem. Or another way of stating it in this problem is that 450 grams is equivalent to 0.45 kilograms. Okay, so we have 3 different methods to choose from. You can use the table, you can use conversion factors to cross out units, or you can use conversion factors to set up proportions to convert to different units in the metric system. Whichever method you choose to use will get you the same results. Cool stuff, guys. See you in another video.